Hello, thanks for clicking, and welcome to another Anarculus production. For today's production, you will only see my arm and hear my voice. But don't worry, even though you can't see me, I can guarantee that this lesson will be taught by the YouTube star of Narculus. Narculus, like and subscribe. Today, we'll be working on AP FRQs from previous exams, focusing on accumulation. You should have the questions from the link nearby, as well as your graphing calculator. On this video, I will skip using the calculator when going over the problems. However, I will do the problems in the graphing calculator on a second video that will also be in the post, if you have trouble remembering how to use the calculator. So, with the general stuff out of the way, it's time to get started. So for the first problem that we're going to look at, we're going to work on a problem that has only one rate. So on Friday, we talked about accumulation, the idea that if you're given the rate, let's integrate and you can find the total. So for the first problem, we're going to deal with only one rate, and then we'll move on to something that's more likely to show up on the exam that has two rates. So we're going to look at question number 2 that's on the top of the accumulation day 1 page. It talks about on T 0 to 31, the rate of change of the number of mosquitoes on tropical island at time T is modeled by R of T. So we're going to talk about R of T. So this, let's talk about R of T. R of T is the rate, we'll say it's the rate in, I guess. There really is no rate in, rate out, but we got to call it something. So we'll call it rate in. Is given by that equation, R of T. There are 1,000 mosquitoes on tropical island at time T equals 0. That we'll probably need to know at some point. Okay, so what we have right now is we have an equation that's R of T that's called the rate in. If we're given the rate and we integrate, we would get the total. So there's an equation on top of here, okay, that if you integrate, it would be representative of the total in, right? Integrate this, you'll get that, okay? All right, so we'll need this as well as we start talking about some of these problems. So let's work on question A. Question A says, show that the number of mosquitoes is increasing at time 6. So it says, show that the number of mosquitoes. The number of mosquitoes is the equation up here. This is how you'd find the number of mosquitoes. You'd use this equation. I want you to tell me that the number of mosquitoes, this equation, is increasing. Well, if I want this to be increasing, the question is, how do I figure out if something's increasing? Well, I find its derivative, and its derivative should be positive, right? But the derivative of the total in equation is R of T, the rate equation. So my question to you is this R of T, is it positive at T equals 6? Well, we can find that out pretty easy by just calculating R of 6. So R of 6 would just be 5 radical 6 cosine 6 over 5. Make sure your calculator is in radian mode. It has to be in radians. And if you do it in the calculator, you'll get the answer. R of 6 is 4.438. That number is in fact greater than 0. So since R is bigger than 0, R is positive. That means the number of mosquitoes is increasing at time T equals 6. Okay, so mosquitoes, Q-U-I-T-O, mosquitoes increasing at T equals 6 because R of 6 is positive. That's your answer. That's all you got to say. Now, you do have to mention the T equals 6. It's important, all right? But that's all you do need to say, okay? And that's all you'd have to do for part A. So let's go on to part B. Part B wants us to say at time T equals 6, is the number of mosquitoes increasing at an increasing rate or increasing at a decreasing rate? Okay, so now I want to know, I already know that the number of mosquitoes is increasing. I want to know now if the rate is increasing. So is the rate increasing or decreasing? That's what I'm being asked, right? Is it increasing at an increasing rate or decreasing rate? Well, to figure out if the rate is increasing, I'd have to find the derivative of that equation, which would be r prime. So the question is r prime positive or negative? All right, so that can be done in the calculator. The calculator is allowed on this problem. You'd find r prime of 6 in the calculator using the n-derived key, right? And if you do that properly, you get negative 1.913. Find your final answers to 3 places after the decimal. And since r prime of 6 is less than 0, so it's negative, that means r is decreasing. Then r, or the rate, is decreasing at t equals 6. That's all you got to say. You're all done. Okay? Calculator will do the work for you, but then you have to write your conclusion, a small conclusion. All right? Let's take a look at letter C. Letter C. According to the model, how many mosquitoes will there be on the island at time 31? Round your answer to the nearest whole number. So it says flat out, round your answer to the nearest whole number. It gets rounded at the very end. Okay? Unless it says round your answer, you do not round the answer. You round the answer to 3 places after the decimal. I don't care if it's people, bananas, apples, pears, whatever. Okay? You round your answer to 3 places after the decimal unless they tell you otherwise. All right? So I want to know how many mosquitoes are on the island. Right now I know the rate. If I want to know how many, I'd have to integrate to get the total. So I'm going to have to integrate from 0 to 31, r of t dt. And since I want, this is how many mosquitoes will be accumulated on the island from 0 to 31. But I want to know how many there are. So I also have to add the 1,000 that we started with. Okay, that's in the scenario at the top. It's 1,000 plus the integral from 0 to 31, r of t dt. And if you do that properly, you come out in the calculator with 964.335. So your final answer will be 964 mosquitoes. You don't need units. They don't ask you for units. Okay, you don't need to put them. All right. If they ask you for units, that means the units are worth points. You must provide the units, okay, in your final answer. All right. All right, let's take a look at D. Now, this one is a little bit new, I think. So letter D says, to the nearest whole number, what is the maximum number of mosquitoes on 0 to 31 closed? Show the analysis that leads to your conclusion. So now, the total, I want it to be a max. Well, the question is, how do I find a max? What do? I want to know the max total. So to find a max, you find the derivative of this, set it equal to 0, find the critical numbers, right? So the derivative of the total equation is this one, the rate equation. So I would need to take r of t, set it equal to 0, to find the critical numbers. All right, now you can do this in the calculator. So you can make the graph in the calculator. Okay, you would use the 0 key, right? You go to calculate 0. Okay, after you graphed it, you would graph it between 0 and 31. So your window would be from 0, x equals 0, to x equals 31. Then you use zoom fit. It would give you a good picture. Then you would use the 0 key under the second calculate menu, okay, or second trace you would press. It would give you the opportunity to find the zeros. There are 2 zeros here. There's one at 7.8539.816, and there's another at t equals 23.561945. I have to write them both down. Okay, they're both zeros. Now, the tricky part about these problems is that most of the time, if you go back and look at the question, it says, what is the maximum number of mosquitoes for t between 0 and 31 closed? The interval is closed. Okay? This is an election candidate's problem. We need to do this as an election candidate's problem. There are 4 candidates for the election. T equals 7.8539816. Yes, you have to use the whole decimal. T equals 23.561945. T equals 0 and T equals 31. The 2 endpoints are also under consideration. To figure out which one gives the maximum number of mosquitoes, I would need to figure out how many mosquitoes there are on the island at each one of these values. Some of them are easy. At T equals 0, there's 1,000 mosquitoes. That's what it says at the beginning. At T equals 31, we did it in part C. The answer was 964. Okay, we just did that. All right. At these 2 values, to get the value here, well, you would need to integrate from 0 to 7.8539816 R of T dt and add on the 1,000 you started with. Okay, if you do that properly, you'll come out with 1,039. If we're rounding to the nearest whole number, 1039. And you do the same thing here, okay, at 23 point, so take 1,000 plus the integral from 0 to 23.561945 R of T dt. You do not get more than 1,039. So the correct answer is, well, the question is, what is the maximum number of mosquitoes? The maximum number of mosquitoes is 1,039, rounded to the nearest whole number. Sometimes they ask you for the maximum number. Sometimes they ask you for the time that it happens. Okay, so just be careful. Sometimes the questions ask for 2 different things. All right? All right, so there would be the first problem done. That's done with 1 rate. Now, most of the problems you're going to see on the exam involve more than 1 rate, a rate in and a rate out, okay, and how they compare with one another. All right, it isn't that bad though. It's the same concept. So if we look at the bottom number 2, let's expand it to 2 rates. It says the tide removes sand from the beach at a rate modeled by R of T. So R of T is the rate out. Let me write it the other way. Okay, so the pumping station adds sand, so S of T is the rate in. R of T is the rate out. All right. Now, above these equations, again, same idea. If you're given the rate in, above it is an equation, if you integrate, called the total in. Above the rate out equation is the total out equation. Right? If you integrate the rate out, you get the total out. Okay? If you integrate the rate in, you get the total in. Right? Given the rate, you integrate, you get the total. All right? We're measured in hours from 0 to 6. Closed again at T equals 0. The bank or the beach contains 2,500 cubic yards of sand. Letter A. Here we go. How much sand will the tide remove from the beach over the 6 hours? Indicate the units. So now you must give the units. Okay? You want to know how much is removed, so you're going to have to integrate from 0 to 6, R of T dt. And if you do that, you get 31.815. Just type it in the calculator. Make sure your calculator is in radian mode. Okay, calculator is always in radian mode here for this class. And you're asked to give the units. Well, in the question, it says that both R and S have units of cubic yards per hour. So this is in yards, or cubic yards per hour, the rate, which means that my answer, if I integrate the rate, I get the total. The total must be in cubic yards. Now, you do have to give the units there. They're worth points. That's why they're telling you to give them. All right. Letter B. Letter B asks for an expression y of t, which will represent the total number of cubic yards of sand on the beach at time t. Okay, so the total amount of yards of sand on the beach, well, we got two rates going here, a rate in and a rate out, right? So to figure out the total amount on the beach, I would need to know the total in minus the total out, correct? I mean, that's pretty much logically how it should go, but I also have to consider the 2,500 because it wants to know how much the total number of cubic yards of sand on the beach at any time t. So I got the 2,500 that I start with, plus the integral from 0 to t, whatever time they want me to stop at, s. We have to use a different variable, so we can say s of x minus r of x dx, and that's all you have to write. Okay, notice I'm not writing the actual functions in here as well. You don't have to write them. They've been defined by College Board in the question, so you don't have to write the whole function out. Okay, you just need to write whatever they call r of t, s of t, whatever they call them. You can write them. That is allowed. All right, and that's your answer. Because if no matter what time I plug in here, what would I do? I'd figure out, well, I'd integrate the rate in, it would give me the total in. I'd integrate the rate out, it would give me the total out. I'd subtract total in minus total out and add 2,500 that I started with. Okay, so I'm all done with this. Now, let's go back to part A real quick and talk a little bit about why we didn't add the 2,500 in to part A. If you read the question carefully, it says, how much sand will the tide remove from the beach? It doesn't want to know how much sand is on the beach. It just wants to know how much is taken off. So to do that, you integrate the rate out. The 2,500 has nothing to do with removing sand from the beach. That's just how much sand there was when you started. Okay, so keep that in mind. That is one of the questions or one of the reasons we don't need that 2,500 there. That actually is the reason we don't need that 2,500 there. Okay? All right, let's go to part C. Oh, I erased E of t or S of t and R of t. Hang on a second. Let me put them back here. This is the rate in. R of t is the rate out. And then above this is the total out and total in. Okay? All right, so letter C says, find the rate at which the total amount of sand in the beach is changing at t equals 4. Find the rate at which it's changing. Well, these are the two equations that represent the rate. To figure out what the rate is changing at, you would just need to take S of 4 and subtract R of 4. All right, S of 4 minus R of 4. The rate in at 4 minus the rate out at 4. And if you do that properly, you get negative 1.908. Okay, no ask for units, you don't need to give them. All right, there's your answer, negative 1.908. Okay, all right, let's take a look at part D. Oh, I erased this again. All right, I'm going to try to do it without it. I might need to put it there anyway. D, for t on 0 to 6 closed, at what time t is the amount of sand on the beach a minimum? What is the minimum value? All right, so I'm going to do it. I'm going to put them back here. S of t is rate in, R of t, rate out. If I integrate rate out, I get total out. If I integrate rate in, I get total in. Okay, I want to know when the amount of sand on the beach is a minimum. Well, that would be up here. And to figure out amount, I would need to take total in and subtract total out, right? I want to know when this is a min. Well, how do I find a min? I find the derivative, set it equal to 0, find the critical numbers, right? And I do all that jazz. So total in minus total out, I need to find the derivative of each one of these. But that's these, rate in minus rate out. So I need to set this equal to 0 or these equal to 0 to find the critical numbers. So the first thing I need to do is take S of t minus R of t and set it equal to 0. So the other thing you could do in your calculator is just graph S of t, graph R of t separate, and figure out where they equal each other. Okay, just figure out where they're equal to each other. If you do that, the only place where they're equal to each other is 5.117865. That's the only value between 0 and 6, right? So you're going to graph between 0 and 6. Okay, so again, we're back in the same scenario where this interval is closed. So this is a candidate's problem. Back to an election candidate's problem. My candidates are t equals 5.117865, t equals 0, and t equals 6. Okay? At t equals 0, I already know how much sand is on the beach. There's 2,500 cubic yards of sand. At t equals 5.117865, I could figure it out by doing 2,500 plus the integral from 0 to 5.117865 s of t minus r of t dt. If I do that properly, I get 2492.3694. And at t equals 6, I'd have to do 2,500 plus the integral from 0 to 6 s of t minus r of t dt. And if I do that properly, I'll end up with 2493.2766. Okay, so I'm looking for the minimum. At what time is the amount of sand the minimum? Well, that's at this time. I'm comparing 2492, 2500, 2493. So at this time, it's a minimum. And what is the minimum amount? That amount. Okay, that's my answer. I need them both because that's what it asks you for. All right. All right, so one last question here. It's not on the paper, but it is one that shows up a lot in these types of problems. So I do want to go over it. Okay. I want to know, is the amount of sand on the beach increasing or decreasing at t equals 1? That's what I want to know. Okay, the amount of sand that's on the beach, is it increasing or decreasing at t equals 1? All right, so to do this, the easiest way I think to understand it is to think about, like, for example, a bucket of water. I talked to second period about this. I don't think I talked to first period, though. So if you have a bucket of water and there's a faucet that's turned on and it's pouring water into the bucket, but there's also a hole in the bucket, so water's coming out of the bucket also. All right. I want to know whether the bucket is, the amount of water in the bucket is getting higher or lower. Well, to figure that out, I would need to know, look at it this way. If the faucet that's putting water into the bucket is pouring water in faster than the hole is letting water leak out, then the water level in the bucket is rising, right? Okay, think about it logically. Okay, now compare that with a bucket where there's a huge hole in it, and the bucket, the water is coming out of the bucket extremely fast because there's a big hole in it. If when the faucet's on, if the faucet's not on fast enough, right, then the water in the bucket, the level is going to be falling. So to figure out if the amount of sand on the beach is increasing or decreasing at t equals 1, I would need to calculate two things, s of 1 and r of 1, and compare them to one another. If the rate in is greater than the rate out, well, then that would mean that more sand is being put on the beach, right? Sand is being put on the beach faster than it's being taken off. So that would mean that the amount of sand is increasing. Okay? And then vice versa. If R of t is bigger than, or R of 1 is bigger than S of 1, then the sand is being pushed off the beach faster than it's being put on. So that would mean that the amount of sand on the beach is getting smaller. It must be decreasing. Okay? That's a problem that shows up a lot that you would often see on the exam. You'll probably even see on the homework today. So that's one way to solve it. I think that's the easiest way to understand. Okay? That'll take care of these two problems. All right? You're going to work on a couple problems for homework on accumulation, and then we will continue working on some AP problems this week. At the end of the week, we will take a quiz. All right? Have a great day, and as always, thanks for clicking.